The engine itself, as already has mentioned, is a 3.3 liter GDi engine. We went from a 3.5 liter MPI to a 3.3 liter GDi. And what that means is the fuel system pressure goes from about 3.8 bar to about 150 bar, so much higher fuel system pressure. What that allows us to do is cool the intake charge when it comes in, and allows us to up the compression ratio. So the compression ratio of the engine rises from the previous 10.6 to 1 to 11.5 to 1. So a much significant increase in compression ratio. It also gives us a capability to have a much higher power output. This is at 290 horsepower. Previously with the 3.5 liter we are at 276 horsepower. So we've increased the power, and that gives us about an 87.9 horsepower per liter, so very aggressive specific output, much greater than most of our competitors in this range, in this market segment. What that really translates into efficiency. Well, we've done a lot of things in the engine here to try and improve the efficiency. And examples of that are, in addition to the compression ratio I mentioned, we have dual continuously variable intake and exhaust cam phasers. We have a three-step induction system, a variable induction system. We've gone to a lot of coatings with regard to the pistons, rings, and tappets to try and reduce friction. We've also gone to a oil control ring, for example. That's typically, conventional systems are a 3-piece oil ring. We've gone to a 2-piece oil ring and dropped the load on the oil ring from 2.6 kilogram to 2.2. What that does is reduce the friction on the bore, so it improves fuel economy since you don't have as much tension on the actual bore. So the pistons can go up and down smoother. We've gone to variable displacement oil pumps, so you don't have high requirements of oil feed. It varies based on the need, the oil pressure required. And we also have added oil jets on the bottom of the pistons so that under high and heavy load conditions, such as trailer towing, the piston can stay cool and you don't get detonation problems. And so this helps performance as well as durability. So we've done a lot of things with regard to the engine itself to try and improve the durability, reliability, and performance and efficiency of the powertrain. Now I'd next like to talk a little bit about the performance. When I talk about performance of the vehicle, I'm really talking about more than just 0-60 or quarter-mile times. I'm really talking about drivability. Our engineers in the U.S. spend a lot of time developing the drivability for North American customers, since this is our primary market segment here. And when I talk drivability, I'm talking about the way you drive on a daily basis, the light tip-ins, medium tip-ins, the near-to-stop maneuvers, those type of things that drivers do on a daily basis. And we sort of coined a philosophy for how we want to calibrate the vehicle, and we called it controlled aggression. What that really means is that on a day-to-day drive, the vehicle is very comfortable and controlled to drive. But when you need it and you want a fast response, put your foot on the accelerator pedal, you'll get very more aggressive downshifts, and you'll be able to get into that passing gear and be able to perform the way you want to perform when you need to perform it. So that's this controlled aggression philosophy.